Okay, bearings. We've got to start with a good diagram, so let's give it a shot. Camp, 70 degrees, true. 4 kilometres out to Andrew, and that's 70, so that must be 20. Okay, Brendan, 3 kilometres, that's 210, so that must be 30. Let's just get rid of that. Okay. Let's see if I can do this. Nearly got there. Okay. The red thing is the important thing. That's the line, the bearing, the vector, whatever you want to call it. That's the resultant. We need to find everything about that, the distance, the bearing, the angles, everything. Generally, when we get to a bearings question and we need to find the angle, we would put this into component form, and we're going to be finding the east-west of the first leg and the east-west of the second leg, and we would be putting them together, I guess, to find a total horizontal east-west component. We'll be finding the north-south component of leg A and the north-south component of leg B, and bringing it into, how many colours have I got here? Purple. So we're going to add the 2 greens together to get the purple line and the 2 orange lines together to get the blue, and everything else then goes away. And it's really easy to use Pythagoras to find the red line, and the angles are really easy to find using tan. Let's just undo all of that. There we go. Okay. So this thing's bearings 2 ways. We're going to do it the hard way. So pretending if we didn't find the bearing, we would definitely just go straight to the cosine rule. So in the middle between here is 90 degrees, so that means all of that is going to be 140. And there's our x. So if it's just finding the distance, we wouldn't even think about using the components, which is what I just scribbled out, because it's too hard, too long. 3 squared plus 4 squared. Because if we just use the cosine rule and our calculator, we get that x is 6.58, and we've done that really quickly and really easily. The bearings, however, is a completely different kettle of fish. So if I was doing this in the exam, I think I'd use the component way, which I just rubbed out. But let's do it the hard way, so you know how to do it no matter what. Because there will be times where you've got to use this way. Let's just say you don't know that, the distance Andrew went. Then you're going to come back to this one. Okay. Let's go blue. The distance, the bearing of Brendan from Andrew is that. That's our bearing. Hopefully you can see that this angle there is going to play a part in that, and it does because of, let's go green, let's do a north-south line there and a north-south line there, and that's Andrew's walk, and that bearing was 70 degrees. So that means that's 70 degrees. So if I find that angle, that means I can find that angle. And all of a sudden that bearing is easy to get. It just pops out. So here we go. We're trying to find, let's call it theta. You can see how messy that diagram is, which is why this is fraught with danger, which is usually why you do the component way to get a bearing. But anyway, 6.58 and an angle opposite, we're looking at the sine rule. So sine 140 on 6.58 is going to be sine theta, that angle, over the side opposite, over 3, and you're going to use your calculator, and you're going to get theta is 17.04. So all of a sudden, that's 17 degrees, which means this blue angle in here is 52.96 plus the 180 gives us our bearing of 232.96 degrees per the answer. Now that is completely doable, but can you see that diagram? There's just so many ways that you can make a mistake there. If you're good with geometry, it should just work out. With a lot of practice, it will work out. But I think my preference would be for the components to put that together. So practice both ways, because you likely need both ways in the test.